Alright, now I'm going to show you how to do a meridian calculation, and we're going to be using exercise 3, number 3. Okay, and if we look at the question, you would have seen that the first part of the question is just a normal sun reduction, and then the second part of the question says the yacht then sailed on a course of 080 true, where the meridian altitude of the sun's lower limb was 63 degrees 12.0 south, and the log read 436. So this second part is a meridian. So you would have done the top bit, okay, and if you wanted to see how to do a normal sun reduction, there's the video before which you can do, see it in there. But I'm going to show you now how to do the second part of our actual of the calculation, which would be our meridian. Okay, so first things first, let's just take the information that's given to us in the second part, and we're just going to put it directly into the pro forma. Okay, so the sun's lower limb, okay, so it was 63 degrees 12.0, and it's south, and it is a lower limb. I'm just going to put that next to it there. Our index area and our dip, okay, are going to be the same. Okay, the same sextants are going to be used, and we just use it from within the question. And if we look up, you'll see it in the top part of it says that the index area was 1.2, and it is on the arc. So if it's on, I'm taking it off. I'm going to put a minus there, and our height of I is 4.0 meters. Okay, I can now go from sextant altitude down to true altitude, and then I will do the steps from there onwards. Okay, all right, so if we look at it, okay, 12.0 minus 1.2 will be 10.8, 63 degrees 10.8. I use my nautical almanac to find my height of my eye. Okay, and I'm going to have a look. And my height of eye is 4 meters. 4 meters, go up, minus 3.5 is my correction. So I put that in here. Minus 3.5. And I'm going to get a 7.3, 63 degrees 07.3. Okay, alter corrections. Okay, go to my nautical almanac, and I'm looking for 63 degrees 07.3. So 10 to 90, sorry, 10 to 90, 0 to 10, 63 sits between 10 and 90. My date is June, so I'm between April and September. There's my sun, and I'm going for 63. So I come down here. 63 fits between 61.50 and 67.15, and I'm looking for a lower limb. So my correction is going to be between there will be plus 15.5, plus 15.5. And add this all up. It's 5. It's 63 degrees 22.8 south. Okay, now you'll see there's a line of arrows and there's 90 degrees. Now, what I've done is my sextant reads 63 degrees 22.8. So I'm seeing the sun, and it's to the south of me. Okay, so the angle of the sun is 63 degrees 22.8. Okay, now in relation to the sun, okay, if I'm seeing the sun to the south of me, I must therefore be into the north of the sun. So just follow the arrows down. If it's south, you bring it down, you then circle the north. Okay, then you'll see it says TMZD, True Meridian Zenith Distance. And how we work out the True Meridian Zenith Distance, which is basically the distance between the sun to us on the celestial spheres. We're going to subtract whatever our sextant reads from 90. So I'll just do the math on the side here. So we go 90, 0, minus 63 degrees 22.8. Make that 89, and it brings 60 minutes over to here, so make that 60.0. Okay, start from the minutes. Okay, I'm going to have to borrow, so I'm going to make that a 5, and then make that a 9, carry the one that's 10, that's 2, that's a 7, that's 3, That is going to be a 6 and 2. 26 degrees, 37.2 minutes. So bring that over here. 26 degrees, 37.2. That is now my true meridian zenith distance. That's a distance from the heavenly body to me, the observer. Okay. Now, if I know how far I'm away from the heavenly body, now I just need to go find where the sun is situated. So I need to find my declination. Okay. So what I do now is I come up to the top box over here. And the box over here is worded a little bit differently, but it says Sun Mer Pass. Okay. The Sun Meridian Passage. Now, where do we find this? We find this in our daily page, okay, of our nautical almanac. Okay, the day we did this was the 22nd of June. So we take our nautical almanac, and we're going to go look for the 22nd of June on our daily pages. Here, on the 22nd of June, the bottom corner over here, you'll see it says day 20, 21, 22. Okay, the equation of time. Okay, and then it says Mer Pass, and if we line it up, you'll see it says 1202. So on the 22nd of June, the sun will be at its highest point in the sky at 1202. Okay, so we take that number and we're going to use it. So this day 22 and it is 1202. Our next line down, it says DR long. And what we're going to do now is we're going to take our longitude, which is given to us. It's up here on the top of the pro forma. Okay, and we're going to convert our time using this longitude, 157.06 minutes east. Okay, now, if we're to the east of Greenwich, what do we do to our time to get to Greenwich? We must subtract. So this is going to be, whatever number we're going to find is going to be a minus. We put the minus there. We then take our nautical almanac and we go to a conversion of arc into time. Conversion of arc into time, and we're going to take our longitude of 157.06 east. So 157 come down here. Sorry, 157 gives us a correction of 10:28, which is hours and minutes. So 10 hours and 28 minutes. We then come across here to our minutes. Our minutes, 0. We're going looking for 6 minutes. We come down. 6 minutes gives us 0.24, which is 0 minutes and seconds. So 0 minutes, 24 seconds. I add that to my 10:28. So I have 10 hours, 28 minutes, and 24 seconds. Okay. I round that up or down to the nearest minute, which will be 10 hours and 28 minutes. So I'm going to use 10 hours and 28 minutes. 10 hours, 28 minutes. It's a minus. Okay, so therefore what I'm going to do is I'm borrow an hour, make that 11, make that 62. Okay, make this 5, make that a 2. So 12 minus 8 is 4, 5 minus 2 is 3, 11 minus 10 is 0, 1, and on the 22nd. So my meridian passage was 1202, but the actual GMT time of meridian passage was 0134. So 134 on the 22nd. Okay, no day change the same. Okay. My next step now is I need to take my meridian passage time of 0134 minutes GMT and I go find my declination for the sun at that time on the 22nd. So I take my daily page, in my nautical almanac, I'm going to go back to the 22nd of June. It's the sun, 20, 21, 22, and my hour is 1 o'clock in the morning. So I look at 1 o'clock, and all I'm looking for is my declination. I don't need anything else but my declination. And you look there, it says 23 degrees, 26.2. Okay, so I write that on. 23 degrees, 26.2, and it was north. Circle the north. Okay, before I leave this page, I go down it. Is it getting bigger or smaller as I'm going down the column? It's getting smaller. And my D value at the bottom of the page is 0.0. So it's negative 0.0. Now I take that D value and I go into my minutes page of 34 minutes. So we go to the back of the nautical almanac, look for 34. 34, and I'm using a D value of 0.0, and I go to 0.0, and it gives me a correction of 0. 0. It's going to be minus, so anything taking minus away, the number is going to stay the same. 23 degrees, 26.2 north. That is now the position of the sun when I did this meridian. So I take the 23 degrees, 26.2. I'll bring it down here to my calculation. 23 degrees, 26.2. So north. And what we're saying here is that we're saying the sun is at 23 degrees, 26.2 north. And we to the north of the sun by 26 degrees, 37.2. Okay, so if the sun is north and we to the north of the sun, therefore we add the two together, and that'll give us the observed latitude that we are standing at this particular time. Okay, so in this case we're going to add them, right? If they were both south, so we're north and north, we add. If it's south and south, we add. But if they're opposite to each other, a north and a south, then we would subtract them. Okay, so in this case we're north and north, we're going to add. That's a 4. That's 13. That's 5. 6. It's 9. It's 0. That's going to be 50. 50 degrees, 03.4 north. And that's how we do a meridian calculation for a sun-run meridian. Now, when we go plot this, what we're going to end up doing, this observed latitude, okay, in this case, because it's a sun-run meridian, will be my LOP2. So you would go onto your plotting sheet, and you would find 50 degrees, 03.4 lines straight across, arrowheads on the end, and that would be LOP2.